Hello and welcome to this episode in our series on mastering deep learning with Python. And we're still continuing our learnings on Numpy. And I want to remind you once again, if you have not subscribed, to subscribe to the channel and click the notification bell so that you get notified when I publish new videos. Okay, so in the previous video on reshaping, I spoke a lot about the fact that when you reshape an array, you are not creating a copy of the array. You are just getting a different view of what is in the underlying memory of the array. And so reshaping doesn't actually change what is in memory. It just restructures it before returning to you. And because they point to the same memory location, I mean the reshaped array and the original array point to the same memory location. If you change any one of them, it changes the other. And so this video is about memory views and copies, where I'm going to show you what I actually meant by this and then how to make a copy if you really want to. And all this has been done for efficiency. Numpy was to be efficient in terms of memory usage and then speed of processing. So it keeps your data in a contiguous block of memory, and then it gives you all these functions like copy and then reshape to be able to manipulate the original data on the fly. But then the structure in memory remains the same. Always remember that the sizes of your Numpy arrays are fixed, but you're able to manipulate the shapes using any function that Numpy gives you to make it possible to be able to do that. Okay, so like always, I'm going to use examples to explain this to you, and I'm going to start by creating an array. So I'll say A is equal to np.arange. I want an array of, let's say, 10 numbers, and then I'll reshape it into 2 by 5. So I'm intentionally using this code up here so that you get a chance to remind yourself of all the things we have learned up to this point. You know what the arange function does, you know how the reshape function works, and you know why I'm using -1. If you don't know any of these, then I would really advise you to go back and watch the videos that I have created on these specific topics. So you want to learn about the reshape, you want to learn about how to generate arrays, and then you also want to learn about how to index arrays before this video will make sense to you. Okay, so I'm going to print a.shape, and then you can see that this is a 2 by 5 array. If I print it out, you can see that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because that is what the code is supposed to return. Okay, what if I want just the first row? I will say first row is equal to A0. This is something you need to know because I have showed you how to do indexing in Numpy. If I print first row, you see that it contains just the first row of the array A. Now you know of a function called may share memory. Let's see if first row shares a memory with A, which of course is true because first row is just a pointer to the first row of the array A. So I'll say np.may share memory, first row, and then A. Indeed, I am expecting a true, and that is true. Okay, what happens if we go and then we change first row? So I'm going to add, let's say 10 to everything in first row. So I'll say first row plus is equal to 10. Okay, now let's print first row. And you see that everything in first row has 10 added to it. Now let's go and get our surprise. I print A, and you see that everything in the first row of A also has 10 added to it. And this actually makes sense because the whole idea is first row points to the first row of the array A. And like I have kept reiterating, it points to the same memory location. It's just a different view. Okay, so think of something that is masking the original array so that you only see what you're supposed to see. So if you modify it, you're actually modifying what is in memory. Okay, what if I want to change things without actually affecting what is in there? Then you want to use copies. So let's say second row is equal to A, and then I get the second row. Let's see if they share memory. And of course, it's going to be true, so I'm not even going to do that. What if I didn't want it to share memory? Then I'll say dot copy. If I do dot copy, let's come and then say mp dot may share memory second row, and then the original array. And you see that over here it is false because I use a copy function. What a copy function does is, of course, gives you a copy of what is in memory. So now it is an entirely new array that has been constructed from that aspect of memory. So if I change anything in second row, I don't expect my original array to have changed as well. So if I come here and say second row plus is equal to 10, let's say we add 10 to everything. So let's print second row. Yes, it has changed. And then let's print A. And you can see that the second row of A didn't change because I used a copy of it. Okay, so now this is our A. The reason why the first row of A changed is because up here we did first row plus is equal to 10. And because first row shared a memory with A, it actually ended up changing what is in A. But second row was a copy. So I got a second row of A, but I made a copy of it. So any change, and you can verify from here that may share memory said false. So any change I do to the second row doesn't actually affect the underlying array, I mean the original array in memory, because second row is just a copy. It's like go to A, make a copy of the second row and store it in second row. Henceforth, anything that I do with second row doesn't affect A because they do not share memory location. And this is the idea of memory views and copies. One more example. So now let's create I'm going to say data is equal to mp dot once. Let's create 10 of them. Yeah, let's create 10 of them, and then I'll reshape it into a 5 by 2. I'm going to put -1 here. Let's print data, and so it's just going to be an array of ones, and then is 5 rows by 2 columns, and every entry is 1. What if I want to change everything in the first column, I mean the second column, which is here? If I want to change everything there to maybe 2, I can say second column is going to be equal to data, the entire array, but then I just want the second column. So let's see what's in second column. Of course, it's going to be 1, 1, 1. Of course, second column is going to be 1, 1, 1. Now let's do second column. Second column times is equal to 2. I multiply everything in second column by 2. Let's come here and print data, and this shouldn't be surprising to you at this point because second column was just pointing to the second column of data, and then I multiplied everything in there by 2, and so data has its second column element multiplied by 2. This, ladies and gentlemen, is how you can create copies or get memory views. So always have an understanding that this modification that I'm doing to this particular value, is it pointing to the memory of the original array, or is pointing to a copy? And having an understanding of this is going to save you a lot of troubles, and these troubles can be very subtle unless you really understand what is going on. So thank you very much for watching. Don't forget to subscribe, and I'll see you in the next video.